We've been looking at quadratic equations, but there's some other types of equations that we need to get familiar with too. Section 1.6 deals with some of those other types of equations. Notice there's 6 different kinds, and this set of notes will cover the first 3. Anytime you want to pause the recording to write stuff down, that's a great idea. Let's look at the first type. Rational equations that give you a linear solution, that's just an equation with fractions in there. So the first step, and I'm putting my hands with little stars by them, get all the denominators the same. Take a look. Notice I've got a denominator of 2 and a denominator of x plus 1. We multiply those together to get a common denominator of 2 times x plus 1. Now notice something else. We've got x cannot be negative 1. If you look at the original equation, if x were negative 1, we'd have a 0 in the denominator of the second fraction. Can't do that. So I start making my denominators the same. I multiply the 2 times x plus 1, and then I multiply the 2x minus 3 by x plus 1. So in other words, I'm just multiplying by 1. And the second fraction, I'm multiplying the denominator by 2 and the numerator by 2. That'll make both of those denominators the same. Once they're the same, then I can just start using FOIL. So x times 2x gives me 2x squared. X times minus 3 gives me minus 3x. 1 times 2x gives me 2x. And then 1 times negative 3 gives me negative 3. I move to the second fraction. 2 times 5x gives me 10x. Now notice those are all over the same common denominator. On the right-hand side, I've still just got x. I combine like terms, and that gets me to here. Let's continue on the next page. Now I've got this, and I want to clear out that fraction. Now notice we're assuming that x does not equal minus 1. So if I multiplied both sides by the denominator of this fraction, it'll make that denominator go away on the left. So that's what I'll do. Notice on the right-hand side, I've got 2x times x plus 1. I go ahead and distribute the 2x, gets me to here. I'm seeing 2x squared on the left and 2x squared on the right. Those will cancel out, which leaves me this. And I go ahead and solve it, and x equals 3/7. Now notice that is not the negative 1 that x couldn't be. If I wanted to go back and check it, I would plug that number into my original equation. Here comes another one similar to this. First thing I do is find a common denominator, which is 4 times x plus 1, and I look and see that x cannot be negative 1 again, because that would give me a 0 denominator. So I want to make both denominators look the same. I just copy down the problem. On my first fraction, I multiply top and bottom by x plus 1. Because that's what I need to multiply by to make that denominator look like our common denominator. Second fraction, I just need to multiply by 4. When I do that, and then FOIL the top, I get 4x squared plus 3x plus 4x plus 3 minus 8x. That just comes from foiling the x plus 1 with the 4x plus 3, and then multiplying 4 times 2x. Now notice that second fraction is a negative, so that's why the 8x is negative 8x. I combine like terms and I get to here. Once again, I want to get rid of that denominator on the left-hand side. So I'm going to multiply both sides by 4 times x plus 1. When I do, I get what's shown here, and when I multiply the 4x times x plus 1, I've got what you see. I've got 4x squared on both sides. That'll cancel. I start combining like terms and solve, and I get x equals 3/5, which is okay because it's not -1. Again, to check that answer, I'd go back and plug it in my original equation. Now then, this type of rational equations, notice again we got fractions, but this is going to give us a quadratic solution, meaning two different solutions. How do I know? Look at that x squared in the denominator on the right-hand side. That's how you tell. My hint here is factor your denominators before you do anything else. So that's what I'm going to do. So on the right-hand side, I've really got x times x minus 3. Now to find the common denominator, I'm seeing in my left fraction x minus 3, my second fraction x, and on the right-hand side, x times x minus 3. Well, all I need is one of each of those different kinds multiplied together. So my common denominator is just x times x minus 3. And notice now, x can't be 3, because that would give me a 0 denominator. And x can't be 0, because that would give me a 0 denominator. I just write all my stuff down again. I know on that first fraction, I have to multiply by x to get my common denominator. So I do that on top and bottom. My second fraction, I need to multiply by x minus 3, top and bottom. When I distribute the x in the first fraction and multiply times x minus 3 in the second fraction, I get x squared minus 5x plus x minus 3 over that common denominator, and my right-hand side doesn't change any. Take a look. The denominator on the left side and on the right side are the same, which means if I multiply both sides by x times x minus 3, it'll clear out all my fractions. So I solve, it's just basic algebra 1 at that point, and notice I get x minus 2 squared, because the line above it, x squared minus 4x plus 4, is a perfect square trinomial. I solve and I get x equals 2, which is an okay value because it's not 3 or 0. Here's another one similar. First thing I do, I want to factor the denominator on the right-hand side. So it's the difference, 2 squares, so I get x plus 5 times x minus 5. That means x cannot be 5, and it can't be negative 5, because that would give me zeros in the denominators. Now my common denominator, notice, is going to be x plus 5 times x minus 5. So I take each denominator and multiply times what it's going to take to make it like the common denominator. Now everything's over the same denominator. I multiply x minus 5 times x, which gives me x squared minus 5x. On the second fraction, I'll multiply x plus 5 times 5, which gives me 5x plus 25. Notice we got our common denominator now on both sides. But the minus 5x and the plus 5x cancel out, which leaves me this, after multiplying both sides by that common denominator. I go ahead and work this out, and I get my answer is either -5 or 5. Don't make the mistake of thinking you're done, because go back and look. What two values could x not be? 5 and minus 5. So that means this thing has no solution. These work rate problems are real easy if you just understand the basic idea. So I'm using Bob here as an example. If his rate is 1/8 of a job in an hour, that just means each hour he gets 1/8 of the job done. It's that simple. So in the example, if he works 5 hours, he's got 5 times 1/8 of the job, or 5/8 of the job finished. You're multiplying the rate times time. And the little formula shows you that. Well, now, if the job gets completed, that A on the right-hand side is just 1. So we've got rate times time equals the amount of work done. And here's my hint. Always find the rates first. It's going to make these problems a whole lot easier. All right, example 5. Read the problem. And we see that Joe's rate is 1/3 of the job per hour, because he can paint the whole house in 3 hours. Sam's rate is 1/5 of the job per hour, so Sam's slower. But the question's asking, how long does it take them to do it together? So we're looking for an amount of time that I'm just going to call t. I get my equation by saying Joe's rate, 1/3 times whatever time it takes both of them to finish the house, plus 1/5, Sam's rate, times that same amount of time. They're working the same amount of time here in this problem, equals 1, because the whole job would be done. I can rewrite that as t over 3 plus t over 5 equals 1. Our common denominator is 15. So I make my denominators into the common denominator, and I get 5t plus 3t over 15 equals 1. Which means the time that both of them can paint the house, in other words, how long does it take them both to paint the house at the same time, is 15 over 8 hours. So that's almost 2 hours. Is that a reasonable answer? Well, if you think about it, Joe can do the house in 3 hours, and you would expect the time that both of them would paint the house to be less than 3, because Joe could have done the job by himself in 3. So this is a reasonable answer for this problem. All right, this is a similar kind of problem. We're going to use the same techniques. So we read it. Now this time they're giving us the time that both of those pipes can fill the pond. And they're making the rate a variable. So if I let the slow rate be 1 over x, and the fast rate has to be 3 times that fast, well, wouldn't the fast rate just be 3 over x? In other words, 3 times 1 over x. Get my formula. So I've got the slow rate times 12, because they told us 12 hours, plus the fast rate times 12 equals 1 entire pond filled. I can rewrite that as 12 over x plus 36 over x. And I just start working it out. So x is 48. I'm not done yet, though. X is 48, but they're asking how long will it take? Well, that's t, some amount of time. Now, they are asking for the amount of time for the faster pipe, so I put the fast pipe's rate, which is 3 over 48, times some amount of time equals 1. Now we're looking for the time. So this is really a two-part problem. A little trickier, but notice we're using the same technique just twice. I get to here, and then it's just Algebra 1. Is that a reasonable answer? Well, yeah. If both of them can fill it in 12 hours, it makes sense that one of them is going to take longer than that, even the fast one. So 16 hours, that's at least reasonable. Last one here. This pool has an inlet pipe and an outlet pipe. Blake leaves them both open. So how do we go about solving this one? Because it's wanting to know how long did it take to fill the pool. So we get their rates. In other words, the inlet rate is 1/5 because that pipe could fill the pool in 5 hours. The outlet pipe rate is -1/8 because it's emptying the pool. And it would take 8 hours for it to empty the pool. I get my formula. Notice the negative sign there. I rewrite it. And now I've got to get a common denominator. Well, for 5 and 8, that's 40. Which gives me 8t over 40 minus 5t over 40 equals 1. Well, 3t over 40 equals 1. Use a little bit of algebra and 6th grade math here. And I get t equals about 13.3 hours. So even though the inlet pipe could have filled the pool in 5 hours, it's got water running out as it's trying to fill it. So I'm thinking this is probably a reasonable answer too. Anyway, that's the first 3 types of problems in section 1.6. If you got questions, get with me.